Welcome to Funny Math. In this video, we talk about multiplication and division of algebraic fractions. In our last video, we discussed addition and subtraction of algebraic fractions. So if you have not watched that video, you can scroll through my videos and watch it. It's a nice video. Don't forget to subscribe to my channel, like, and comment as well. So let's begin with our first question here. We have to simplify this one. 5x squared y over 6ab times 18a squared b cubed 15xy. How do we simplify such an expression? So you see, these are algebraic fractions and we are multiplying them. So how do we simplify this kind of stuff? So let's do something here. Let's begin with simplifying numerical fractions, how to multiply or also divide numerical fractions. So assuming we have, let's say 2 on 4 multiplying, let's say 12 on 8. How do we simplify this? For multiplication of fractions, we can just multiply the numerators and the denominators separately. So we can just multiply 2 by 24 to get, 2 by 12 to get 24, and then 4 by 8. But then we can do simplification. We can cancel out our expression before before you multiply. So in this case, we can use these two to cancel 8. That is 2 here, 1. 2 into 8 is going to be 4. 4 can also go into SF1. 4 goes into 12 3 times. You see, that would make the work easier. So we'll be getting 1 out of 1 times 3 out of 4, which is going to be 3 on 4. That will be the final answer. So you see, it's very simple. We just do cancellations and then we multiply. But if you multiply them direct without cancelling out or before simplifying, it will create a whole lot of problem, or you have to simplify your final answer. So always try to simplify the expression before you multiply. That will help you rather. So let's come to our question here. That is our I. Okay. Remember, we have 3 questions here that we're going to solve. The last one is here. So we're going to solve all these questions. So let's begin our first one. Okay. So we have 5x squared y all over 6ab times 18. This is something. Okay. So that's going to be 18 a squared b cubed. That is all over 15xy. So how do we simplify this stuff? Let's see how we're going to simplify this. So we can just multiply 5 by 18. 5x squared y by 18 a squared b cubed. But that will make the work, tougher or complicated. So we can simplify before we just do the multiplication. So in this case, as we go through, we can do cross cancellation. When I talk about cross cancellation, that is using, let's say, 6 to cancel out 18 here. So that is cross cancellation. You can also do vertical cancellation if only it is possible. So in this case, I don't think that is possible here. We can do vertical cancellation. 5 cannot go into 6, and then that of 18 and 15, maybe you can use 3 to do that. But that's not what I'm going to do here. So I will just do cross cancellation, and that will be quite easier. So let's see how we're going to cancel out here. Okay, so you can see that 5 can go into SF 1 time, that is 1, and it can go into 15 3 times. And then 6 here can go into SF 1, 6 goes into 18 3 times. Okay, so we can also come to the letters. We have A and that of A squared. A goes into SF 1 time and it goes into A squared A. This is the reason. A going into A squared means A squared divided by A. And according to the laws of indices, we just take, one of the denominators, one of the bases, that is a, then we subtract their exponent. You see, this one has an exponent of 1, so that's going to be 2 minus 1, and that will give us a. And that is why we're getting a here. Okay, so this is what we have. We can still simplify some of the stuff here. We have b and that of y. So let's simplify b here. So we have b here and that of b cubed. B goes into itself one time and it will go into b cubed, b squared. You get it? And s goes into itself. So let me use this ink for that. So x goes into itself one time and it goes into x exponent 2x. And lastly, we have y and that of y here. So y goes into itself one time and here one time. So let's see what we have at the moment. So on the first fraction we have, x. We have, okay, so that's going to be x on 1. You see the whole of the denominator here has turned 1 times, you have 3ab squared on 3. So at this moment we can still simplify. 3 can go into itself one time, so 3 here 1, 3 here 1. So we're going to get x times ab squared. X over 1 is the same as x, so we're going to get ab squared x, and that will be the final answer. So you see, it's not difficult. So we are just cancelling out, we are just dividing, and then we multiply. So let's come to the second question, and that is here. Okay. All right, so let's begin with the second question. That's a whole lot of stuff, but it's not difficult as well. This is similar to the first expression. So let's see how we're going to simplify this question. We have 35 x cubed y cubed all over 8b exponent 5 q, we don't have any exponent here, then divided by 7xy all over 64 pq times 8p exponent 4 q exponent 4 all divided by 5x squared y exponent 2. So how do we simplify this one? So this is a combination of division and multiplication. You know that's for multiplication, for division of algebraic fractions or numerical fractions. Let's use numerical fractions for now. If I give you, let's say, 2 on 3 divided by, let's say, 3 on 9, we have to change this division sign to multiplication. So it's going to be 2 on 3 times, and we find the reciprocal of this fraction. So that's going to be 9 on 3. So just turn this one upside down. So the same thing that we're going to do here. So we change the division sign here to multiplication, and we find the reciprocal of the next fraction. So this is how the whole thing is going to be. So we have 35 x cubed y cubed all over 8p exponent 5q. And then we change this guy, that is division, to multiplication. Then we have to find a reciprocal. So it's going to be 64 pq all over 7xy. Take notice of that. The last one, okay. So the last one is going to be this times 8p exponent 4q exponent 4 all over 5a squared y squared. So we only find the reciprocal of the next fraction, which is this one, not the third one. So take notice of that. So at this point, we have to simplify. We have a whole lot of stuff. We can do cancellations. So let's simplify. Let's simplify. So I can see 8 in that of, 64. So 8 goes into itself one time. It goes into this 8 times. 7 goes into itself one. It goes into 35 5 times. You can do a whole lot of cancellation here. So let's see. P. This is P exponent 4 goes into itself 1 and it goes into P exponent 5 P times. So this is what we do. We always use the one with a smaller exponent to cancel the one with a bigger exponent. So that you have to take notice of that. So let's come to this one. We have x cubed, y cubed. X has a smaller exponent. So that's going to be x here 1. And it goes into x exponent 3. That is x exponent 2. So let's take the other one. We have y here 1. And this goes into this one. Y exponent 2. We can cancel more. Let's see this one. Kill. And out of this kill, we can still do that. So q here 1. It goes into this one. 1. Okay. 5 can go into this 5. But I want us to write what we have at the moment. And then we continue from there. So let's do that. Let's write what we have at the moment. So we have this expression. Okay, let me check it well. So we have 5x squared y squared out over p. We are getting 1p, 1 times p times 1. That's going to be p. So just write p. So times. This is going to be 8p out over 1. All these guys have 10 1. So we are going to get out over 1. And then times 8 q exponent 4 out over 5a squared y squared. We can still simplify. After going through the expressions. We can simplify. P here 1 and p goes into this one time. Let's talk about 5 here 1, 5 goes into this 1, and then we have y squared here 2. So y squared 1 goes into this one time. So I think that is what we can do. We don't have any a in the numerator or in the numerators here, so we can simplify that one. So let's see what we're going to get at the moment. So we have x squared. You see, it has 10 over 1, so we can just leave it like that. But if you want to bring it, you can just bring it like this. So x squared over 1 times this one, we have 8 over 1 times 8 q exponent 4. This one we have a squared here. You have to check it well. That is a squared. Okay, let me get my squared well. So that's going to be a squared. Okay, so at this moment we can't simplify again, so we have to multiply. For multiplication of fractions, we just multiply the denominators and the numerators separately. So let's multiply. So we have x squared times 8 q exponent 4. So let's multiply the numbers. 8 times 8 is going to be 64. So you have 64, x squared q exponent 4 out over a squared. So that is the final answer. Okay, so let's come to the last one. Okay, so the I is similar to the I. So let's see how we simplify this one. So we have 25 a squared b exponent 4, divided by a whole lot of stuff here. So let's begin. We have a division sign here, so we have to change this one to multiplication. So that is going to be, 25 a squared b exponent 4, all over 11 x exponent 3 y exponent 7, times 66 c d out over 5ab. So we have to change this division sign to multiplication, and then we find the reciprocal of the next fraction. So that's going to be x exponent 4 y exponent 6 divided by 2b cubed. Okay, so this is what we have. And let's see how we're going to simplify further. So we have so many stuff here to cancel out. So let's see how we can begin this thing. All right, so we have 5 here. So 5 goes into SF1. It can go into 25 5 times. And then we have a here, 1. A can also go into a squared, goes into 8a. B goes into SF1 and into this b cubed. Let's move to the other side. We have 11 here. 11 goes into SF1 time, goes into 66, 6 times. Which one again? We have y exponent 6 and that of y exponent 7. You have to use the one with the smallest exponent to cancel the one with the larger exponent. So that means you're going to use y exponent 6 to cancel y exponent 7. So simply, y exponent 6 here, 1, and it goes into y exponent 7, y times. So this is what we have. And then x exponent 3, x exponent 4. So x exponent 3 here, 1, goes into x exponent 4, x times. So let's write what we have at the moment and see whether we can simplify further. Okay, so this is what we have. We have 5a b cubed out over, y. That is 1 times y. So that's going to be y. So times. So this is going to be 6 cd all divided by 1. If I div all 10 into 1, so that is what we're going to get. And then times x over 2b cubed. So that's what we have. You can still do cancellations here. I can see that we have b cubed here, and out of b cubed here. So we just cancel them out. So we have b cubed here 1. It goes into this 1. Which one again? We have 2 here. 2 goes into SF1. Goes into 6 3 times. From that result. So we can't do any cancellation again. So this is what we're going to get. We have, okay, so let me write it here. So we have 5a out over y times 3cd out over 1 times x over 1. We can't do any cancellation again considering the numerators and the denominators. So we have to multiply. So just multiply the numerators and the denominators separately. So let's see what we're going to get here. So 5a times 3cd times x. Now 5 times 3 is going to be 15. So we have 15 here. So a times cd times x is going to be a cdx all divided by y. So all divided by y, which is the same as 15. We have 15 a c dx y exponent negative 1. So this is the same. Remember, 1 over y is the same as y exponent negative 1. That's according to the laws of indices. So take notice of that. So that would be the answer to this expression. In fact, you can leave your expression or your answer as this, and you're correct. If you want to continue with this part, no problem. Okay, so thank you for watching. See you in our next video. Bye.